Cosmology has changed forever due to the launch of the James Webb Space Telescope on Christmas Day, 2021. Since then, Webb has opened its impressively sharp, high-resolution infrared eyes to look back at the earliest stages of the universe, gathering sharp, pristine, and breathtaking insights into early star and galaxy formation. The telescope has also provided profound insights into the formation of planetary systems, including our very own solar system. But here's the twist. James Webb was almost too good, far exceeding all hopes and expectations. Astronomers expected to find some of these infant galaxies with Webb, but they never expected to find so many. Webb's unprecedentedly deep views revealed a colossal surprise, a multitude of seemingly impossible early galaxies. At the earliest times, these galaxies appeared too big, too bright, and too numerous to explain. Some of them even seem older than the universe itself. Our best cosmic predictions, based on the lambda-cold dark matter model, the standard model of cosmology, didn't expect what James Webb saw. In other words, these discoveries might shake the very foundations of our understanding of galactic history. So, does this mean the Big Bang and all of modern cosmology are in trouble? Join us as we dive deep into how James Webb has uncovered massive structures that could defy our current theories of the universe. The farther back we look into the distant universe, the more we expect to see a particular pattern. At some point, we should find the first bright, large, luminous galaxies. We expect to see their number density rapidly decrease as we approach that limit. Before this, we should only find smaller, less evolved galaxies, decreasing in number and density until we discover the very first among them. And before even that, we expect to see only individual star clusters in protogalaxies, primitive and extremely blue, existing in low numbers. Finally, there should be a time when the very first stars and star clusters appear. Beyond this point, there should be no luminous sources at all to observe, except for the Big Bang's leftover glow. But James Webb's findings are forcing us to ask a profound question. How did the universe grow up and come to be the way it is today? Given our model of the universe, a mix of dark matter, normal matter, dark energy, and a bit of radiation, we can predict what we should see in the universe at any given time. Looking at these distant objects with the James Webb Space Telescope, especially using its spectroscopic capabilities, allows us to test this model and see if we truly understand the universe we inhabit or if we need to revise our picture of the cosmos. The James Webb Space Telescope is changing astronomy in ways we never imagined. From peering into the atmospheres of exoplanets to capturing stunning images of distant cosmic phenomena, its contributions are vast. But perhaps its greatest achievement is its ability to observe galaxies so distant that looking at them is like looking back in time. Projects like Webb's Source, Cosmic Evolution Early Release Science Survey are scanning the sky to pick out some of the oldest galaxies we've ever seen. When scientists first turned Webb towards seemingly empty patches of sky, they found something astonishing. They didn't just find a few old galaxies. They found far more than anyone had predicted. According to Michaela Bagley of the University of Texas, one of the leading source researchers, the theoretical models didn't predict that these should be there. One particular galaxy jumped out of the source data straight away, Maisie's galaxy, named after the daughter of Stephen Finkelstein, one of the researchers. At 13 billion years old, it's one of the oldest galaxies ever observed, much brighter and bluer than anyone expected. As Bagley put it, when we found Maisie's galaxy, the surprising part was how does it in the universe? It's exciting and a little mind-bending to think that this is the universe we live in, a universe with far more galaxies than we ever thought. James Webb is able to detect these extremely distant galaxies because its instruments operate in the infrared wavelength. A small number of extremely distant galaxies have been detected previously by the Hubble Space Telescope, which primarily operates in the optical light wavelength, what our human eyes can see. But as galaxies move further and further away from us due to the expansion of the universe, their light shifts toward the red end of the spectrum in a process called redshift. The most distant galaxies that early universe researchers are interested in have light that is so redshifted, it's no longer visible in the optical spectrum. It can only be seen in the infrared. While Hubble's instruments were pushed to their limits to detect even a few of these galaxies, Webb detected many of them incredibly quickly, within just a few days of beginning its science operations. When discussing these galaxies, Scientists typically refer to their age rather than their distance. You'll often hear them describe a galaxy as being from the first few 100 million years after the Big Bang rather than being located billions of miles from Earth. This focus on age is because the expansion of the universe creates a moving frame of reference, making it challenging to describe distance meaningfully. For example, Maisie's galaxy is described as being 13 billion years old. The light has traveled 13 billion years to get to us, but if we could see Maisie's galaxy today, it would be much, much further away due to the continuous expansion of the universe. Initial estimations of the redshift, and thus the age of Maisie's galaxy, were based on photometry, a technique that analyzes brightness in images using a small number of wide-frequency filters. These calculations suggested the galaxy had a redshift of 11.8, but Finkelstein and the Sewers team wanted a more accurate age estimation. To do this, they made follow-up observations with James Webb's Near-Infrared Spectrograph, NIRSpec for short. This allowed them to examine spectral lines created in light data, dictated by the absorptions and emissions of chemical elements at specific wavelengths. From there, they could pinpoint the actual redshift of Maisie's galaxy, which turned out to be 11.4. This means Maisie's galaxy is technically seen more recently in the universe than initially estimated, by a factor of tens of millions of years. Nonetheless, it is still considered immensely old. James Webb captured the galaxy as it was just 390 million years after the Big Bang. This impressive age places Maisie's galaxy among the 4 oldest galaxies in the universe that have had their ages confirmed by spectroscopy, a technique that splits light into its component frequencies to better reveal its brightness, heat, and chemical composition. While such galaxies don't yet pose problems for leading models of cosmology, they suggest that galactic formation began earlier and proceeded faster than expected. Previously, theorists predicted that the universe began churning out galaxies at the ripe age of 1 billion years after the Big Bang, but we're seeing the rise of massive galaxies much sooner than we thought. So, what does all this mean? James Webb's discoveries could have profound implications for our understanding of dark matter, the formation of galaxies, and the very nature of the universe itself. Scientists had already produced models of what early galaxies would be like, and James Webb contradicted them almost immediately. As soon as Webb began looking for early galaxies, it found far more of them than anyone had predicted, and they were much brighter too. Light is a double-edged sword in the context of these galaxies. It's what lets us study them, but there's so much more of it than astronomers expected. Imagine it like this. It's like walking into a kindergarten and finding a teenager. How did these galaxies get so massive so quickly? We've only begun to scratch the surface of what James Webb will reveal. The universe is full of surprises, and it seems that with every new discovery, we're forced to rethink what we thought we knew. The high level of structure and brightness in these galaxies is leading some astrophysicists to question the age of the universe. In an attempt to explain the impossibly massive galaxies existing so early in the timeline of the universe, a researcher has posited that the universe is roughly twice as old as previously believed. They pushed the age of the universe from approximately 13.8 billion years to roughly 26.7 billion years. That's an interesting scenario, but it doesn't correspond to the evidence at hand. So up to now, there's currently no consensus on what is the root of the discrepancy between the models we have and the data we observe with Webb. The answer could be related to dark matter and its role in the early universe, or it could be that the way early galaxies were formed was spurred on by forces that haven't been considered yet. However, it's worth noting that even before the James Webb Space Telescope, scientists knew that the early universe was a very different place from the universe today. Its galaxies were made almost entirely of hydrogen and helium, were shaped by tendrils of dark matter, and hosted enormous bright stars that lived fast and died young. While the laws of physics haven't changed over the past billions of years, the scale of the universe has, and that affects how those physical laws apply to galaxies. When the universe was smaller and denser, that affected the ways in which stars formed in complex ways. As Bagley explained, if the universe is smaller, the density inside and outside galaxies is probably higher. If it's dense and hot, the gas won't collapse to form stars. If it's dense and cold, then you could get a ton more stars. Another way in which the early universe was fundamentally different is in its overall chemical composition. Heavy elements like metals were almost entirely absent in the early universe because these elements were primarily formed within stars and spread by their explosive deaths called supernovae. It took several generations of stars to spread these heavier elements through the universe and to be absorbed into stars similar to those we see today. The hypothetical earliest stars in existence are referred to as population 3 stars. Today's young stars are population 1 stars, and the numbering counts backward in age. Population 3 stars were thought to be massive, brilliant, and short-lived, creating only the lightest elements like hydrogen and helium. In contrast, population 1 and population 2 stars created heavier elements like oxygen, nitrogen, and carbon. This left us with galaxies today full of heavier elements in comparison to the early universe, in which almost no such elements were present. One of the big surprises of the galaxies spotted by James Webb is that they don't look like they are made of hydrogen and helium alone. As Bagley explained, this means they might be experiencing more vigorous episodes of star formation. And the longer stars form, the more that they pollute the gas they're forming from with elements like carbon and oxygen. All of this means we have a complex, evolving universe, but it's not just evolving slowly, but also evolving incredibly rapidly. We know the universe is still young in astronomical terms, but these results suggest that it might have grown up quicker than we ever anticipated. In the grand scheme of things, James Webb's unexpected discoveries are just the beginning of a new era of exploration and understanding in cosmology. As we continue to probe the depths of the universe, we might find more surprises that challenge our current theories, forcing us to rethink our understanding of the cosmos. So, while the discoveries of the James Webb Space Telescope might seem to pose questions for the Big Bang Theory and our understanding of the universe, they're also exciting opportunities to deepen our knowledge and refine our models. With each new galaxy that Webb uncovers, we're one step closer to understanding the story of the universe, its origins, its evolution, and perhaps even its ultimate fate. The universe is a place of wonders, and the James Webb Space Telescope is our latest, greatest tool for exploring those wonders.